Welcome back, everybody. Week 11, Math 2. We're working on optimization and integration. So this is using derivatives. Basically, the idea is we'll have a word problem. Yes, I know everybody's favorite. And from the word problem, we will find a function, and then it's going to say either find the maximum or find the minimum. In either case, that's where the derivative equals 0. And then when we go on to integration, for the second half of today's show, that's going to be the opposite of the derivative. But first, some of these optimization problems. So basically that right there is the theory part. And now I need to practice because these are pretty much all word problems. So suppose that you know that the sum of two numbers is 20. So maybe it's a 2 and an 18 or a 10 and a 10, something like that. The two numbers add up to 20. And then the product needs to be maximized. In other words, when you multiply the two numbers, it needs to be as big as possible. All right. So basically we're looking for a situation like this, where we set the derivative equal to 0 and find out where there's the maximum. But first we need to create a function. So the sum of two numbers is 20. So I can just say the two numbers are going to be an x and a y, and they have to add up to be 20. Next, their product. So I'll just use the letter P for product, and then product means multiply them. So basically this equation right here, I can solve for y. So I'll just subtract x from both sides, and it's going to say y equals 20 minus x. And then I can take this and substitute it in for this y right here. So it's going to say the product equals x times, and then replace the y with 20 minus x. And I could even multiply this out by distributing the x. So there's going to be 20 times x, and then an x times a negative x will be negative x squared. And then the good news is that this makes an upside down parabola. So it looks like this, and right here at the top, that's the maximum. And since it was asking for a maximum, that's all good news. And now for the derivative. So I'll just call it P prime. And the derivative of 20x is just 20. The derivative of x squared is 2x. And then set the derivative equal to 0 like I was advertising over here. So 20 minus 2x equals 0. Or add 2x to both sides, and 2x equals 20. And then just divide by 2, and that means that x is equal to 10. So divide by 2 and divide by 2, I get x equals 10. The last thing to do is take that x and put it right here, and then y is going to be 20 minus 10. So that means that the two numbers are 10 and 10. All right, there's one example. And then on to another example. So with this one, so for example number 2, so with this one, a farmer is making a rectangular pig pen. And so that's the rectangle. And then the farmer is going to build it up against the side of a wall that already exists. So this wall is like a brick wall that the farmer has out in the farming area. Sorry, I'm trying to write and talk at the same time. Anyway, this wall is 10 feet long. So in other words, the farmer doesn't have to build anything right there. But then they do have to build this part, which I'll call X, this part, which I'll call Y, this part, which, because it's a rectangle, these two have to be the same. And then on the bottom, this is a total length of 10 plus X. Okay, that's the first setup. Next up, the perimeter, in other words, the amount of space all the way around. So the total perimeter equals 200 feet. So basically this was already built. The farmer has 190 feet of fencing to make this and this and this and this. And then the question is going to say, what's the maximum area for the pig? Because of course we want the pig to have as much space as possible. Okay, so basically like with the last one, we need to come up with two equations. One is going to be this, the perimeter. So that means 10 plus x plus 10 plus x plus y plus y. So when you add up all of the sides, or I could just say I've got two of them that are 10 plus x, and I've got two of them that are y, and then that total perimeter equals 200 feet. And I could simplify this because this could be divided by 2, and this could be divided by 2, and this could be divided by 2, which is a great time for me to use the red pen. Divide by 2, divide by 2, and divide by 2. Then it's just going to leave 10 plus x, and now I don't need parentheses right here anymore, plus y equals 100. And like with the last equation, I could go ahead and solve for y and either do that now or do it in a minute. So I might as well just do it now. So solve for y. So subtract 10 and subtract x, subtract 10 and subtract x. So then it says y equals, this will be 90 minus x. All right. Next up, for the area. So the area is just one side times the other. So the area, and I'll just use an A for that, equals one side times the other side. And then we need to find the maximum. And just like with the last one, you can, since we know what y equals, you can substitute that in. So A equals, so the y is getting replaced with 90 minus x, and then the 10 plus x is still there. That way, my only variable over here is x. And I could go ahead and take the derivative with the product rule and then do algebra, or I could do algebra first and then the product rule. I'm going to do algebra first. So distribute. 90 times 10, that's 900. 90 times an x, that's going to be plus 90x. Now distribute the minus x times 10, so minus 10x. And finally, a minus x times a positive x is minus x squared. Or if I combine like terms right here, the area equals 900 plus 80x minus x squared. Okay, so all of that was to create the function, and now take the derivative. So the derivative here is 0. The derivative here is just going to be 80. And then the derivative here is going to be negative 2x. And then in order to find the maximum, set the derivative equal to 0 and solve for x. So I'm almost running out of paper here, so I need to move over and add 2x to both sides. It's going to say 2x equals 80 and x equals 40. And then this is how long the x part should be. And then I can just go back to this one and plug in the 40 and find out what the y is. So the y would be 90 minus 40, and then 90 minus 40 is 50, so the y part should be 50 feet. So there are the x and the y. Okay, now for the next example, take this same situation, and this time we're going to talk about money. So we'll start with the same picture, the same perimeter, but instead of talking about area, talk about money. Okay, for this next one, we're basically going to start with this situation again. So this brick wall is already there, but then we're going to talk about money. So for example number 3, we basically start with the same rectangle, and this is that 10-foot brick wall that's already there. You could tell it's made out of brick because it's red. Look at that. And then the farmer is going to need to build this, which is x, this, which is y, this, which is y, and then the bottom would be 10 plus x. And then with this one, it's going to be that the long sides they're made out of something cheaper that costs $20 a foot. And the short sides, for whatever reason, they cost a little bit more. They're made out of a little bit fancier material. Perhaps they have to have a gate built into them. So those are going to cost a little bit more. They're going to cost $25 per foot. And then this little pig needs a certain amount of area, and the area has to equal 200 square feet. So find the lengths, or find x and y, to minimize the cost. Because of course we want to build something that's nice for the pig, but if we can do it for the least amount of money, that would be nice. So find the x and y so we can minimize the cost. Well, last one, it said that the perimeter was 200, but this one says the area is 200. So the space in here is 200 square feet, and area is just one side times the other. So that means that area equals one side times the other. And we're given that the area has to be 200, so I can substitute a 200 right here. And I can see that it would be quite easy to solve for y, and my experience on the last one says you're going to need to solve for y so that you can substitute it into the function, so I might as well do that part right now. So divide both sides by 10 plus x. So 200 divided by 10 plus x equals y. Okay, now I'm done with that part. Now to talk about the money. So what about the cost? And I think I'm just going to separate this. I often like to separate them and keep algebra on one side and then the calculus on the other side. So for the cost, I'll just use C for cost. And the long side, so like this side is long and this side, they cost $20 a foot. So we're going to have $20 a foot on this side and $20 a foot on this side. And then the shorter sides cost $25. And then we basically just need to go around the rectangle and add up all the costs. Since this brick wall is already there, we don't have to rebuild it. So on this side, we just need $20 per foot times x. So we'll have 20 times x. Oops, it looks like my pen is leaking. That's okay, I'll survive. And then this is a 25y, plus this is another 25y. So 25y and 25y is 50y. And then on the bottom, you do have to build out this whole 10 plus x. So it's going to be plus 20 times 10 plus x. And we went through all that work to find out what y equals. So that should be substituted right here. And in the same step, I'm going to go ahead and distribute this. So I would have that first 20x stay there, plus 50 times y, and now replace y with this 200 over 10 plus x. And then when I distribute, this is going to be 200 and then 20x. And before I take the derivative, I'm just going to clean it up a little bit. 20x plus 20x will be 40x. And when you multiply a 5 times a 2, that's a 10. And then it would have 1, 2, 3 extra zeros. 1, 2, 3 extra zeros. And then it's divided by 10 plus x. Let's see, did I get everybody? 20x, 20x, 40x. This times this is this. Oh, plus the 200. Okay, now I've got everything. And this does not say 0.40. That's just a blob from my pen. So take the derivative. So the derivative will be, so derivative of 40x is just 40. And now when you take the derivative of this function, this is basically like 1 over x. And the derivative of 1 over x is negative 1 over x squared. Since this isn't just an x, it's a 10 plus x, it still follows the same rule, so it gets squared. And the 10,000 that's on top just stays there. Okay, now take that derivative and set it equal to 0. And it looks like I'm going to need another piece of paper to finish this one. So with this one, what I would do is take this negative term and just move it to the other side so it becomes positive. So it would become a positive 40 equals the 10,000 divided by 10 plus x being squared. The next thing that I would do is get rid of this fraction by saying multiply both sides by 10 plus x being squared. 10 plus x being squared, then these can cancel. And then once this is on this side, I'll just divide both sides by 40. And these will cancel, leaving just the 10 plus x being squared. And then 10,000 divided by 40, I don't actually know in my head, but the calculator says, oh, that's sort of bright, hold on. Okay, that's better. 10,000 divided by 40. Turns out it's a nice 250. And it's a good thing that I've got the calculator here, because the next thing to do is take the square root. And the square root of 250 is a 15.811. And then that gets rid of the square, so we just have 10 plus x. And then the last thing to do is, or excuse me, the second to the last thing to do is subtract 10 from both sides. So x equals, when you subtract 10, that's going to leave 5.811. And now for the last thing. And the last thing to do is find out what y equals. So just use this equation, and then we'll see what y equals. So a 200 divided by 10 plus x, and x turned out to be the 5.811. So for the last one, or the last step on this one, 10 plus 5.881, no, it was 5.811. And then I've got my parentheses, I got my 200. Okay, so 12.649. So the y equals 12.649. Okay, one more of these fun word problems, and then to the antiderivative part. So for example number 4, so this is a sales type situation. And it's pretty common to have these sales type situations. The one that I'm thinking of is when you leave a sporting event or a concert or something like that, there's people outside selling hot dogs and sodas and stuff like that, much cheaper than in the football game or the concert or whatever. So a person sells, and we'll just go with sodas because that's faster to write than hot dogs. So they sell sodas for $2 and sell on average 140 per day. So if you multiply 2 times that, it's $280. And then they decide, you know what? Maybe I should raise the price and make a little more money. But if you raise the price, you might lose some customers. So that's the next part. When that person raises the price by 10 cents, then on average, they lose 2 customers. So in other words, they bump it up to $2.10. Then they're only going to sell 138. So just looking at the math real quick, 2 times 140 means they'd make $280 off of the soda. If they raise it up to $2.10, they will sell 138. So they'll make almost $290. So they'll make an extra $9.80. So that's the idea. So maybe they should raise the price even more. So find the price to maximize revenue. In other words, maximize how much money they're bringing in. And we don't know how much they're paying for these sodas, so we don't know their profit, but how much should they charge to maximize their revenue? So basically, we first need to find the equation of a line, because we've basically got X is going to be the price, and then Y is going to be the number of sodas that they sell. And then I can even make a little table right here. So when X is $2, then they sell 140. If it goes up to $2.10, then they lose 2 customers, so then they're down to 138. And then find the slope. So slope equals, so subtract the 2 y values, so y2 minus y1, 138 minus 140. And then subtract the 2 x values, x2 minus x1, so 210 minus 2. And on the top, that's going to be a negative 2. And on the bottom, it's going to be 2.10 minus 2, so that's 0.10 or 0.1, same thing. And if you have a negative 2 divided by a 0.1, it's actually equal to negative 20. And you might be thinking to yourself, that doesn't sound right. Negative 20? There's no negative 20 in here. Yeah, but it's basically saying when they raise it by a dime, they're going to lose 2 customers. And basically this is saying If they raise it by $1, which is 10 times this, then this has to be 10 times, they'll lose 20 customers. And negative means they're losing customers. So this is basically saying they're losing 20 customers if they raise it by $1. Now find the equation of the line. So I'm going to use this right here and go y minus the y value of 140 equals the slope times x minus the x value of 2. And then I need to clean this up. So on the right side, I'm going to distribute negative 20 times x. And negative 20 times negative 2, that's going to be a positive 40. And then I should just add 140 to both sides. So that means that y equals negative 20x plus 180, right? 140 plus 40 is 180. So this is sometimes in business called the demand function because that's the sales, or in other words, this is what your customers demand, how many sodas they demand. And now for the revenue. Well, like I did earlier, when I take the x times the y, so the $2 a piece times 140, that equals $280. So in general, the revenue just equals x times y. So multiply the price times the sales, that's how much money they're bringing in. And like with the other ones, we already know what y equals, so we can replace this y with this. So revenue is going to equal x times negative 20x plus 180. And I'm going to do algebra before taking the derivative, so distribute. This is negative 20x squared, and then x times 180 plus 180x. And this does make an upside down parabola, so that means it does have a maximum. Sorry, that was off screen. Does have a maximum. So for the derivative, r prime equals, just do the power rule right here. So this times this is going to be negative 40, and now it's x raised to the 1. The derivative of x is just 1, so this is going to be plus 180. And then when you set it equal to 0, we're almost done with it. So I would take this negative 40x and add it to the left side, so it's going to say 40x equals 180, and then just divide both sides, so it's going to be 180 divided by 40, and 180 divided by 40, oh my goodness. So they should be charging $4.50 per soda. Obviously, you can tell that I just made up this example because I think that $4.50, although if you've ever gone to like a professional baseball game or football game or concert, yeah, that's actually pretty cheap if it was inside the arena. Okay, now we're on to the second half of today's show, which is integration. There's another name for it, and that is antiderivatives. So if you have something like y equals x cubed, and then you take the derivative. So just use the power rule, the 3 goes in front, multiply, and then subtract 1 from the exponent, so the derivative is 3x squared. Well, whether you call it integration or antiderivative, what it means is you go backwards. You're given the derivative, then go backwards and find out what was the original function. So when we take the derivative, you take the 3, put it in front and multiply, and then subtract 1. So if you're doing the antiderivative, and this could be example number 5. So if you're doing the antiderivative and it says, okay, somebody took the derivative and they got x to the 7. Then what function was it that they took the derivative of? So basically, instead of multiplying, we're going to have to do the opposite and divide. And instead of subtracting 1 from the exponent, we're going to have to do the opposite and add 1. So the first thing to do is add 1 to the exponent. That's going to be an 8. And then divide by 8. So the original function was x to the 8 divided by 8. And if you take the derivative of this to check the answer, the 8 will go in front, which will actually cancel that 8. You subtract 1 from the exponent will be 7. And yes, that would be correct. Now the thing is, if somebody had a 19 right here, this would also be a correct answer, because when I take the derivative of this, the 8 would still go in front, cancel, subtract 1, it still gives you x to the 7. And the derivative of 19 is 0, which is exactly what's sitting right there, 0. So this could be any number. So instead of using a 19, we just use the letter C. So this is called the constant of integration. All right, this is one notation for it, the way that I just did it. Another way to do it is, just like there's two words, there's integration, there's antiderivative. Well, there's this notation, and you do it this way. Another way to, the notation goes like this. It's like a big S that's been stretched vertically. Oops, I stretched the ink. And then it would say x to the 7 dx. And then you just do the same thing, add 1 to the exponent, so it becomes x to the 8, divide that by 8, and then don't forget the plus c at the end. So the question could be asked this way: if y prime equals this, then what does y equal? Or it could just say this symbol, which means the exact same thing, find the antiderivative. And this symbol right here is called the integral symbol. All right, now let's do some other examples. So on to number 6, and I'm going to switch back and forth between the two notations because we are going to use the two different notations for the rest of the semester, which is only like 3 more weeks. So for this one, what if it says y prime equals, and then we've got an x squared plus 1 over x to the 5 plus 1 over x. So basically we just go one by one and find the antiderivative for each one. So this one right here is sort of a special case because this comes from the derivative of natural log of x is 1 over x. For the middle one, so before I start taking the antiderivative, for this middle one, I do need to rewrite it as x to a negative 5. So right now, basically, I'm just rewriting this one as x to the negative 5. And I'm not going to rewrite this one as x to the negative 1 because I know that this one came from the derivative of natural log of x. So whenever it's 1 over x, then that's just natural log of x. And then just go to this one and add 1 to the exponent, so that's going to be a 3, and then divide by 3. Go to the middle one, add 1 to the exponent, that's going to be negative 4, and then divide by negative 4. And then this one is just going to be the natural log of x. So that means that the, oops, I didn't mean to write y prime. That means that the original y is x to the 3 over 3, and then this one would be minus, And this is x to the negative 4 over negative 4, except I moved the negative over there, so I don't need that negative anymore. And then this one is the natural log of x. And you're right, you don't forget the plus c at the end. And one last little thing is, I don't like to have negative exponents, so I'm just going to rewrite that middle one. So this one is fine. I'm going to rewrite this one as 1 over the 4's in the bottom and the x to the 4's in the bottom. And then just recopy the natural log of x and the plus c. And then wrap it up and send it off. It's ready to go. Then there can be times when, example number 7, so instead of y prime, it might say dy dx, means the exact same thing. And then we've got the square root of x plus the cube root of x. And then there could be some additional information like y, when you substitute 0, you'll get the answer 2. So this extra information is used to find out what c equals. So we'll use this part at the end, and instead of having just plus the letter c at the end, we'll actually find out what c equals. So before I can do the antiderivative, I need to go to each one of these and rewrite it as x raised to a power. Well, when it's square root, that means the 1/2 power. And when it's cube root, that means that it's the 1/3 power. Now go to each one, add 1 to the exponent. So this would be 1/2 plus 1, 1/2 plus 1. If you change that to a fraction, that says 3/2. So this one is going to be the number 3/2, and then divide by 3/2. Oh wait, I did want the red pen for that. Divide by 3/2. Then go to the next one and add 1. So if you have 1/3 plus 1, and you change that to a fraction, that is 4/3. So this is going to be 4/3, and then divide by 4/3. So this red part was us finding the antiderivative. So this no longer says derivative, it says y equals. And then this is going to be x to the 3/2. And the rule for dividing by fractions is when you divide by a fraction, then invert and multiply. So instead of 3 over 2 being on the bottom, there's 2 over 3 on the top. And then the next one will be, so invert this, 4/3 becomes 3 over 4. And then it's x to the 4/3. And then we got the plus c. And if this information wasn't given, then I would be done right now. But because it does give me this information, then I'm going to plug in x equals 0, and it's going to say y equals 2. So in place of y, put a 2. In place of x, put a 0. So each one of these x's becomes a 0. And then it works out very nicely because this is just 0 and this is just 0. So this side only has c and this side has 2. So then I found out what c equals. So all I need to do is take the 2, put it right back there, and then we're done. At least with this one. So you got 2/3 x to the 3/2 plus 3/4 x to the 4/3, and then plus the c, which turned out to be a 2. And then, how about a couple easy, fast ones? Example number 8. What's the antiderivative of the number 14? Well, you look at that one and you go, it doesn't even have an x. And I would say, yeah, well, I sort of agree with you, but 14 could also be written as 14 times 1. And 1 is also the same as x to the 0. So this is basically just saying 14 times 1. But now that we have this, we can say, oh, okay, that means add 1 to the exponent. 0 plus 1 is just 1, and then divide by 1. So this would be 14, and then x to the 1 divided by 1, that's just 14x. And basically, this symbol and this symbol go together to say find the antiderivative, and the variable is x. That way I know that this is supposed to be an x, not a w or a t or something like this. So this part right here is telling you what the variable is. This part is saying find the antiderivative. All right, then I circle it and I say I'm done. And when I get it back graded, there's minus 1 point. You know why? I forgot the plus c. So if there's no numbers to plug in, each and every one of them is going to have a plus c at the end. And then for one that is pretty quick, it goes, suppose that the y prime equals 1 over x plus 9. And y of 0 equals 1. So this one is the natural log. So if you just ignored the 9, that's 1 over x, and that comes from the derivative of natural log. Well, because that has an x plus 9, that means it's natural log, and then inside the parentheses, just put the x plus 9. So there's the antiderivative of that one, then the plus c. And now this one is saying if you plug in a 0, then y will equal 1. So substitute a 1 for y and a 0 for x. And then we could see what the c equals. Well, this is just the natural log of 9. So in order to solve for c, I just need to subtract this number from both sides. So the left side is going to become 1 minus the natural log of 9. And then that's what c equals. 1 minus the natural log of 9 is a negative 1.197. So the c equals negative 1.197. And then here's my final answer. So just go back to right here. Y equals the natural log of x plus 9. And then in place of the c, put that number. Minus 1.197. And there is one more, so please hold on for one more example, number 10. So for example number 10, find the antiderivative. On the top, it's got x cubed plus x plus 9. On the bottom, it's got x squared. And then find the antiderivative. Well, this is a big old fraction, and finding the antiderivative for a fraction can be very difficult. So what I'm going to do is I'm going to take this and divide it into 3 easier problems. And basically it's saying this and this and this have to be divided by x squared. So you could actually do it individually and go take the x cubed, divide by x squared. Then in the middle, take the x and divide by x squared. And then go to the 9 and it gets divided by x squared. So you get divided by x squared, and you get divided by x squared, and you get divided by x squared. And then I'm going to rewrite each one of them so that it's x raised to a power. So in here, when you have one thing divided by another, then you subtract the exponents. So it's going to be 3 minus 2, so it's going to leave x to the 1. And then this one has an exponent of 1, minus 2 is going to leave in the middle x to the negative 1. And then for the next one, this, you could just move it to the top and it's going to say 9 and then x to the negative 2. And then it still has the dx, which is saying what the antiderivative is. And then you go to this one. So you basically just look at it as one problem at a time, add 1 to the exponent, and then that's going to be a 2 and divide by 2. So this one is going to be x to the 2 over 2, so x to the 2 over 2. And then for the middle one, we run into a little problem because I add 1 to the exponent, which is 0, so -1, +1, that's 0, and then divide by 0. And dividing by 0 is not possible. So what happened? Well, this one, I got x to the -1, but if you rewrite that without the negative, that's the 1 over x again. So once again, that one comes from natural log. So this is the one and only time this idea of add 1 and divide by that does not work. And that's when you basically have 1 over x. And when you have 1 over x, you just say that came from the derivative of natural log of x. Okay, disaster averted. Next, add 1. So this is going to be -1 and divide by -1. So then it's going to leave plus 9 and then x to the -1 divided by -1, and then don't forget the plus c. And one last tiny thing is I don't like any negative exponents, so I'm just going to rewrite that one. And for one thing, it's a negative, so I'll just put that in front. And then this x to the -1, to get rid of the negative, the x goes to the bottom. And then there we go. Now it's beautiful.